Hello, welcome to Physics with Amol sir. So this video is for class 9th. So we had a test last week. Most of you performed very well in that test. Okay, and those who were not able to score also, no problem. Make sure that in the next test you will score marks. Now today we are going to go back to our chapter of motion. Okay, so there was one topic that I had left behind. Okay, that topic was the topic of graphs. Now the reason was that I did not have a blackboard at that time. So today I have a blackboard, so I can teach you the concept of graphs very easily. Okay, so let's begin. So I hope you remember the concepts of motion very well. Okay, today we are going to see the concept of graphs. Now we have a general idea of what is meant by a graph. A graph basically helps us to understand, to see how one quantity will change with the other quantity. Okay, and of course we are going to see only two-dimensional graphs. So our graphs will have two axes. Okay, this is the x-axis and this will be the y-axis. This will be the origin. Okay, at the origin the coordinates will be 0, 0. Okay, so this is basic structure of a graph. And we are going to see two types of graph. First type we are going to see, they are called as the distance time graph. Okay, so these type of graph will give us the relationship between distance and time. Okay, so let's begin. So let us see a simple case. So we have a case like this. X stands for distance and t stands for time. So an object is having a motion such that after 5 seconds it covers a distance of 1 meter. After 10 seconds it covers a distance of 2 meters. After 15 seconds covers a distance of 3 meters, so on and so forth. Okay, so this is the motion of an object. We want to make an xt graph, that is a graph of distance versus time. So what we have done, on the x-axis we have taken the time, and on the y-axis we have taken the distance. Okay, always remember, time will always be taken on the x-axis. Now let us plot the points. The first point, as we said, time is 5 seconds. So here we have 5 seconds. For 5 seconds, how much is the distance? It is 1 meter. So the graph, the point will get plotted here. Okay, 5 for time and 1 for distance. Second point is at 10 for time and 2 for distance. So 10 for the time and 2 for distance. This is the second point. Third point is 15 for the time and 3 for the distance. So third point will be somewhere over here. And so on and so forth. We can get all the other points like this. Okay. Now if we join all the points, you will see that we get a straight line. Okay. So this is a graph. This line is basically called the graph of distance versus time. Fine. Now what do you notice about the line? You notice that the line is straight. Okay, there is no curve in the line. It is a straight line. Why is it a straight line? Because if you can see from the motion, okay, obviously you can understand this kind of motion is a uniform motion. Right? You know it is uniform because in equal time intervals, equal distance is being covered. Okay, so this is a uniform motion, and because it is a uniform motion, we can see the graph is a straight line. So our understanding is the graph, the xt graph of uniform motion is always a straight line. Okay, let us see a second case now. Second case we have, in 5 seconds distance is 1 meter, 10 seconds it is 3 meters, and in 15 seconds it is 7 meters. Just by observation you can see this is not a uniform motion. Okay, this is a non-uniform motion. Then what we can see, if we plot the points, for 5 the first point comes here, second for 10 the point comes to 3, somewhere over here, and then third for 15 the point goes up to 7, so it will be much higher. If we now try to join these points, we can see that they are not in a straight line. Okay, now the graph tends to curve. Okay, so what we understand from this, if it is a non-uniform motion, in that case the graph will not be a straight line, it will be a curve. Okay. I hope that concept was understood. If there is any doubt, please don't forget to ask. Now let us go back to the original graph, that is graph of uniform motion. Okay, so this is an xt graph once again. Xt means distance versus time. Okay, so here we have distance and here we have the time. Now if an xt graph you see a straight line, immediately you will say the motion is uniform motion. Okay, that is an indication for us whether motion is uniform or no. Okay, if the xt graph is straight line, it is a uniform motion. Okay, so an xt graph can also help us to find out speed of the object. Okay, how it will help us? We can find something called as the slope of the graph. Okay, so slope of the graph gives us the speed of the object. Of course, now you will ask how to find out slope. You can select any 2 points on the graph. So I am going to select this point. I will call that point as A, and the second point I will call that as B. Okay, and then from B you can extend it here, and A you can extend here. You will see now we are getting a triangle like this. This point let us call that as C. Okay, now you can see there are two sides here, AC and BC. Okay, so slope of the graph is given by AC upon BC. That is the Y side divided by the X side. Okay, so AC divided by BC. Now, how much is AC? You can see AC is this much, 3 minus 1. So AC is equal to 2 meters because this was the distance. How much is BC? BC is the time, 15 minus 5. So it is 10. So 10 seconds. So 2 upon 10. How much is 2 upon 10? It is equal to 0.2 meter per second. So this is the speed. Getting it? So what we understand? The slope of an xt graph gives us the speed of the object. Okay, so we can find out what is the speed of an object by finding out the slope. And how you will find out the slope? You make a triangle like we have made, and it is AC upon BC. Okay, the Y side divided by the X side. Okay, if an object is at rest, okay, what will the xt graph look like? Let us say we have a car, okay, and the car has moved by some distance and it is standing at a distance of 10 meters. Okay, so there is a car which is standing at a distance of 10 meters. Suppose this graph here it is 10. After 5 minutes, it will still be at 10. After 10 minutes, it will still be at 10 meters. Okay, if we join, the graph looks like this. Okay, so if an object is at rest, the graph will be a straight line parallel to the x-axis or the time axis. Okay, so this is how you can understand whether the motion is, if there is motion taking place or if the object is at rest also. Now, let us interpret some graphs. Okay, now we don't need the values also. I am going to remove the values. But remember, this is the time axis and this is the x-axis, that is the distance axis. Okay. Now, let us say there are two persons. Okay, there is a person P and a person Q. The xt graph of P is this. Okay, so this is xt graph of P and this is xt graph of Q. Understanding? When P is moving, the graph looks like this, and when Q is moving, the graph looks like this. Observing the graph, can you tell me which of them is moving faster? Okay, how we can understand? For this, you have to see the slope of the graph. If you look at P and you look at Q, which is having more slope? Definitely Q is having more slope. And because Q is having more slope, that means the speed of Q is higher than the speed of P. Making sense? Okay. So just by observing the graph, you should be able to tell whether one object is moving faster or slower. So in this graph, you see that Q is moving faster than P because it is having more slope. Okay. Second thing you can see from this straight line graph, that means both of them, they are moving at a constant speed. They are having uniform motion. Okay. Right. Now my suggestion for you is you are going to go through the textbook material on the graphs. Okay. Today we have seen xt graphs. In the next class we are going to see vt graph, that is the velocity time graphs. Okay. You should be able to observe a graph and you should be able to interpret what is the meaning of that. Okay. Thank you.